Hello guys, we are continuing with one-dimensional motion. This is Ashil, she's my daughter. I love her. She's also interested in physics, even more than us. Let's go. Now I want to analyze one-dimensional motion in a situation that we have constant acceleration. So in such a situation, as I said, it is a constant acceleration. So if I draw the constant acceleration diagram, acceleration actually time diagram, it is something like this, constant acceleration. So its slope is 0 because it is constant through the time. And the next diagram I would show you is actually velocity time diagram, vt, which has a constant slope, and its slope is showing us the acceleration. So this is the initial velocity. And the other is actually our displacement diagram with respect to time, xt, which should be a polynomial equation diagram, something like this, let's say. And it is important that everywhere it must have an increasing slope because the velocity is increasing, but the acceleration is constant. I mean, well, like this. So here in this situation, if we are moving in x direction, our dvx over dt, the differential of our velocity with respect to time, equals to a, which is a constant. And if I do this, dvx, if I multiply both sides to dt, a dt, and then by taking the integral from both sides, it would be something like this, integral of a dt. Then it becomes vxf minus vxi, because it is from initial to final point, equals to a times tf minus ti. And I want to put this ti equals 0, this tf equals t. So it becomes at. Okay? And another thing that we had, as we remember, is average velocity. Because our velocity is increasing through the time, constantly. I mean, like this, with a constant slope. So average velocity would be vx bar equals vxf plus vxi, let's say, over 2. Actually, the average of initial and final points in a time given. Okay? Then, as you know, delta x over delta t equals v bar of x here. And as I said, this delta x is t, actually, like this, I said. Then xf minus xi equals v bar x times t. This equals, like this, I want to substitute this, vxf plus vxi over 2 times t. Then if I substitute again this vxf, it equals at plus Vxi over 2 times t. It equals um, half of a times t squared plus Vxi times t. So this is a good equation you should memorize probably. Delta x equals, as you can see, a over 2 t squared plus Vxi times t. Okay? And this is also important, as you can see here. Actually, Vxf, your final, velocity would be the function of acceleration times t times time plus initial velocity. So, another thing that I want to tell you, which is really important, is that we had this, Vxf minus Vxi equals a times t. T can be obtained like this: Vxf minus Vxi over a. Then also we have xf minus xi equals half of a times t squared plus Vx times t. If I substitute t from this equation to this, it will be a over 2 times Vxf minus Vxi over a, all of it to the power 2, plus Vxi times Vxf minus Vxi over a. This equals Vxf squared minus Vxi squared equals 2a times delta x. So it means that your final velocity to the power 2 minus your initial velocity to the power 2 equals 2 times the acceleration times your displacement. So let's have an example of these things. The example is that I have a car. This is a diagram I have in x direction. This is 0 point. This is 60 meter after 0 point. I have an object here. I have a car here. My object is xi equals 0. My object acceleration is 4, but it doesn't have any initial velocity. But my car has its location, it starts from 60 meter. It is in this location already, and also its velocity is actually 60 meter per second, and it has a constant velocity, so its acceleration is 0. That when my object reach to the car, the object can be a robot or whatever it wants to be. So actually, the final location of xf of my car should be the same as final location of my object. All right. So to do this, actually, I should obtain the equation of my car in final position. Well, the equation of displacement for car here, because it doesn't have any acceleration, but it has initial velocity. It is 60 times t plus the initial position 60 meter. The other is the displacement of my object. I mean final displacement of my object. It is just half times 4 times t squared, because it has just an acceleration but without any initial velocity or initial point. So they should be the same. It means that 60 times t of c, let's say, when the object overtake the car, 60 times tc plus 60 equals 2 times t squared. to Tc squared. Then it becomes Tc squared minus 30 times Tc minus 30 equals 0. Then you will obtain the final answer is around 31 seconds after they start to move. Okay, thank you very much. It was a very good session. See you soon.